Good afternoon again. I apologize about that. Whenever my headphones turn off and somehow don't link to the Bluetooth, essentially it stops recording. So, this is the second part of the guided practice for lesson one of Unit 9. Essentially, I was telling you that we have another parallelogram FGHD, and we have some diagonal lengths that we know. And I'm just going to write them down. So, there's another theorem that I want you to know about, especially when we're looking at diagonal lengths. This is on page 805 in your textbooks. It's very important. And essentially, it tells you about diagonal lengths. And I'm just looking at our textbook right now. So even though the first example problem in the textbook goes over diagonal lengths, it doesn't actually show you this theorem on page 805. It shows you one that's slightly different. But I'm just going to show you. If we have a parallelogram, I'm just going to label it F, G, H, and D. Essentially, if you have diagonals connecting the opposite sides, we know that there's going to be some congruent parts to it. And essentially, what I'm going to show you that right now. So we know that if you're looking at opposite angles like F and H, these segments of the diagonal are going to be congruent. So F to this point is going to be, we'll just label that as, I'm just going to label it as M. So F to point M and H to point M are going to be congruent, and D to point M and G to point M are going to be congruent. So that makes sense because we're trying to solve for two variables right here. We have a variable for y that we don't know, and also for w. But we do know that this point for G to the point, I'll just label it M again, is congruent to that side, and F to M and H to M are congruent. So what I'm going to do for y is, since I know that this segment is equal to 8y plus 2, and this segment is equal to 34, I am going to have 8y plus 2 equals 34. And I'm also going to have the other equation where it will be 7w minus 5 is equal to 44. And now we're just going to solve for the variables. So I'm going to first subtract 2 to both sides of the equation to get y by itself on one side of the equal sign. 34 minus 2 is 32. And lastly, I'm just going to divide both sides by 8. And so I'm going to get y equals 32 divided by 8, which equals 4. So y equals 4. And I'm going to do the same thing for w. I'm going to add 5. So 7w equals 49. I'm going to divide both sides by 7. So w equals 49 divided by 7, which is 7. So again, when we're looking at diagonals of a parallelogram, we just need to pay attention to some key components. They're from page 805. If two diagonals of parallelograms that basically connect each opposite angle intersect, the point of intersection, I called it M, is going to make two different congruent parts. So these two segments that go from the opposite angles will be congruent, and these two segments will be congruent. And that's where we set this 44 equal to 7w minus 5, and then 8y plus 2, I set it equal to 34. All right, so now we're going to start the independent practice, and we're going to do number 9 through 11, 15 through 17, and number 26. And that will conclude lesson 1. Just logging into the Chromebook right now. It went to sleep. Okay, so for number 9, your homework wants you to do 9 through 12. I'm probably going to do 9, 10, and 11, or just 9 and 10 since it's the same type of problem. It's just wanting you to apply some properties of parallelograms that we were talking about in the guided practice. So we have parallelogram L, M, N, and P, where side LN is 8, NP is 12, and then this angle right here, angle P, is 72 degrees. Basically the exterior angle of angle P, because the interior angle for P is right here, but the exterior angle for P that's connected to this extension, this exterior angle is 72. So number 9 wants us to find the angle for L, and 10 wants us to find the length of NP, and 11 wants us to find the measurement of angle M. All right, so let's look at those. When we're looking at this type of problem, we have the measurement of angle L. So the properties that we looked at earlier about parallelograms says that I know that this interior angle for P is going to be congruent to L. So we don't know this interior of P. However, we can find it because we have at P, the exterior angle is 72. We could find this angle because this whole thing right here makes a straight line. This whole angle right there makes a straight line. So in order to find the interior angle of P, we're going to take 180 degrees and subtract 72. And that's going to give us the solution for the interior angle of P. And that is 108 degrees. So we know that this interior angle is 108 degrees for P. 108 plus 72 makes 180, so that would be correct. And because these two angles, angle L and the interior angle of P, are congruent, that means that angle L is 108 degrees. Now we want to find the measurement of MP. We want to find this length. Well, we know that based on the properties of parallelograms that we talked about earlier, the opposite leg, or the opposite side, not leg, is congruent. So if LN is congruent to side MP, if LN equals 8, that means MP also equals 8. Okay, so now we're going to look at the measurement of angle M. So we know that the measurement of angle M is going to be congruent to the measurement of angle N. This brings us to another property of parallelograms that we can discuss. I just want to see how the book is having you do it. It's fairly straightforward, a way that I was taught. And the book also shows it this way. If we have two angles that are not opposite in the parallelogram, so I'm just going to write it. So right here, if we have angle L and then we add angle N, that's going to be 180 degrees. Same thing, angle M right here plus angle P is going to equal 180 degrees. So again, the opposite angles in a parallelogram are congruent, but the angles that are next to each other and not opposite, they add up to 180 degrees. So if we're looking for angle M and we know that P is going to be 108, we know that angle M plus the measurement of angle P, which is 108 degrees, equals 180. And all we're going to do is take 180 and subtract 108 degrees, and angle M is going to equal 72 degrees. So that's kind of cool. And I'm going to show you a neat little trick. Based on parallelograms and their properties, we know that LN right here is parallel to MP. I'm just going to draw those little arrows to indicate they're parallel. And if they're parallel and you have an extension of a line, this means that these two angles right here are going to be the same. This exterior angle formed by P right here is 72, and this interior angle of N is going to be 72. And it's because these two lines are parallel and these two lines are parallel, it's going to have what's known, as we've talked about many times before in other units, consecutive angles. These two angles are consecutive angles, angle N and the exterior angle of P. But the book wants you to basically take, since we know angle M and angle P are add up to 180, you're just going to, in order to find angle M, take 180 and subtract 108 and get 72. All right, so that concludes the problems for number 9 through 11 of the independent practice. We are going to now look at number 15, 16, 17, and number 26. There are still a couple more problems for you to do in the independent practice, but I wanted to go over these since we're not in class and we're having to do online instruction. I wanted to basically break the problems down to help you understand them so that you'll be prepared for when you take the test. Anyways, let's move on and continue on with the independent practice. So number 15, let me just log in again. This Chromebook goes to sleep. I gotta change the setting. It just keeps going to sleep on me super quick. So number 15 says find the value of each variable in each parallelogram. So we have another parallelogram, JKLM, and we have X degrees, Z degrees, and 32 degrees. So they want you to solve sorry, my headphones went off again. Hopefully it doesn't end the recording. but I'm just going to give it a second. Hopefully it doesn't, again, end it. Anyways, it seems like the recording's going, so we are okay. So they want you to solve for x, and they want you to solve for z. These are two angles in this parallelogram that we are going to solve for. And as we discussed earlier, some properties, we know that angle J and angle M are going to be congruent, and angle K and angle L are also going to be congruent. Remember, opposite angles in a parallelogram are congruent. So that means that we know angle Z is going to equal 32 degrees. And that's because angle L is going to be congruent to angle K because they're opposite angles. So we can easily now say that Z equals 32 degrees based on the properties that we've been discussing. And now we could find angle X. Angle X is just going to be 180 degrees minus 32, because angle L plus angle J is going to equal 180 degrees. So doing the math, 180 minus 32, 10 minus 2 is 8. We turn that into a 7, and that's going to be 4, and that's going to be 148. So that's going to be our solution for x, is 148 degrees. So let's move on to the next problem. Okay. I'm going to have to just conclude this segment real quick. I will finish the other 3 problems. There is a student that is trying to get a hold of me, so just give me a second. I am going to do the problems in a couple minutes and finish up the independent practice for lesson 1. Okay?